Quantile regression predicts the outcomes at different points or quantiles of the data distribution. Welcome back to my channel. Hope you all are doing good. Today we are going to talk about or discuss about the quantile regression and its concepts, and we will understand that fully. One note guys, if you are subscribing and while that time you are not hitting the bell icon, you are going to miss the latest updates. So do that so that you will be staying updated with all my contents. Let us start. Let us understand on how quantile regression works. So quantile regression is a type of linear regression, right? Because we are understanding all our regression algorithms. However, in our linear regression, we are using a linear reg line, right, to predict. So what is that reg line? That reg line is a average of all values, where that line will be coming up by getting the average or the least square method, right? However, in case of quantile regression, we are considering different quantiles, such as 10th percentile, 25th percentile, 50th percentile. You will consider those percentiles and you will see how it behaves with different predictor variables. And you could see the same through this image. We can see that, right? I mean, we can see that how it behaves with 10th percentile, then 25th percentile, 50th percentile, then till 90th percentile have taken, and you can see the trend or the pattern is going upward or it is increasing. So with this, we are able to know, right, the correct pattern on how it behaves or how the predictor variable is behaving with the different predictor inputs, right? Then why it is significant? Because here we are understanding, we are not only understanding the median value, however we can see the lower and upper value and different values at different points, and it helps you, right, analyzing data that allows different parts of numbers, not just the average, because here in OLS method we are just understanding the average part. Here we are understanding the different values at different points. So how, let us see on this image how it works, and before that let me take you go through one example and let me explain you how it works. Suppose consider that you characteristics of a person. Okay, a person is having their height and weight, right? In regular regression, we are just considering how height and weight are related on average manner, right? However, in case of quantile regression, we are finding how the shorter person or how the shorter person's height is getting related to the weight, then how a taller person's height is getting related to the weight, like that, and we will come to a conclusion. So with that, what we understood, okay, not all height is going to be same, or not high, or like the behavior of height and weight, we are exaggerating more with this quantile, and we are understanding, or we are diving deeper manner inside the different variables and the patterns of them, right? So the same thing we are observing here. You can see that these are various inputs, right? You can see that these points, there are different points or the different criteria present in each point, right? And when we're talking about 25% or the 25th quantile or the 0.25 quantile, in that case we are seeing my value is coming 10, right? And we are taking that 10. That means we are understanding, okay, with 0.25, my value is coming as 0.10. Then with 50% or our median value, my median value is coming 90. And with the 75% or 0.75 quantile, I am getting 26. So with that, I am able to understand, okay, my trend of the data is increasing, right? And there are few advantages of my quantile regression over my normal regression. Those are nothing but one we can say that it is really good in understanding the observation and to find out the outliers. If outliers are present, then we can analyze them and we can find them, right? And if like in case of quantile regression, we are not making any kind of assumptions on the distribution of target variable, because in case of normal regression, we are considering the average line, that is our standard, and we are comparing different values or different independent variables accordingly. However, in case of quantile, we are understanding each and every point. We have that feasibility to do that here, right? So these are our few advantages. However, in case of quantile regression, one more important point or one more important factor you need to understand, that it helps in detecting heteroscedasticity or the heterogeneous of the errors. I will give you one example here. Suppose, let me take it to the whiteboard and show you what is the difference between homogeneous and heterogeneous output. So when we are considering a normal scenario, this is our normal scenario. So in a normal scenario, how it is happening? So these are your different points, right? And those points, when it is going ahead, so these are your points. Like this, it is there. So these are your points. And right, this is my regression line. So when I'm talking about error or the residue part, we always used to observe that how the errors are behaving at each point. How this error is coming, how this error is coming, what is the difference. So we are understanding always that there should be a homogeneous effect on errors. There should be homogeneous effect on errors. And when I'm talking about heterogeneity, so this is homogeneous behavior of error, homogeneous. That means the trend of errors which it is following between all the points, it should be similar. However, when I'm talking about the heterogeneous or the heteroscedasticity, in that case, what is happening? All my points are something like this. So here it will behave in this way. Then here it will be like this. Some like it is not a same line or the same trend. And if my regression line will cross over it, so you can see that this distance will be more, right? So it will reduce. In quantile regression, this part will be reduced. So it is very useful in this case to understand this pattern and to trigger or to find it out and to solve this, right? You can see here it is not uniform, right? It is non-uniform, correct? So that's the same thing. That is the same thing which we are talking about. Now we will go back to our PPT. So here what we are telling, that it is helpful in detecting the heterogeneous behavior of different variables, right? Now we will understand why we are using quantile regression. Like I've already mentioned, in our OLS regression, it gives the information on how average relationship between the predictor variable or the response are coming up together. However, in case of real world problems, we should dive deeper in understanding the outliers and non-normal errors, whether it is affecting more to the estimates or not, right? So we are understanding that with quantile. And in this one, like in this quantile, right, we are understanding whether we have inequality, risk, or any kind of extreme behavior with 10th and 90th percentile, right? Because 90th is our highest, 10th is our lowest. So with these, we are able to understand whether there is much difference between the trend or not, right? Then quantile regression is helping me to analyze the different impacts of predictors at different points, right? Based on your response variable, right? So you can see the same kind of example I have shown here. So you can see that heteroscedasticity heteroscedasticity, normal distributed target. You can see how my points are distributed. It's not good, right? It's not looking good. And you can see that the plus ones, the plus points are outside your interval. And these are your inside, the black dotted one are inside your interval. Then this blue one, the blue color, is your 0.05. Then this orange one is coming as 0.5, or the median, or the, like, it's coming or aligning towards the average line. Then green one is a 0.95. So you can see that there are so many points, the plus one, you can see there are so many plus points who are there, or the plus symbols, which are present outside of these boundaries. So we are able to understand that we can treat them, right, with this. So that these are the main benefits of going ahead with quantile regression. And when to use quantile regression, like I have already explained, that in case of understanding the tail events or extreme values, we are going ahead with that, like the way I have shown you in the previous image. Then when we are dealing with the data which exhibits the highest level of spread or the heterogeneity, right, where the variances are more, it's not uniform. In those cases, we can go ahead with the quantile regression. And where the response variable or the target variable is skewed, positive skewed or negative skewed, right skewed, left skewed, those concepts I have already explained. Go through that, measures of asymmetry, and understand that concept if you have not done that. So where the response variable is either left side skewed or right side skewed, or positive skewed or negative skewed, and it has outliers, many outliers it is having, right? So in that case, we can go ahead with this. Then there are so many implementations in different fields altogether here. So we are saying finance, healthcare, and marketing. There are different wide range of applications of this. And it is a famous algorithm which is getting used at the same time. So in finance, when we are saying that we are estimating the risk factor, right, and the different portfolios are there of different assets. So in that cases, we are telling that, okay, we need to set these predictors and we need to understand the pattern, whether how it is affecting the risks of those portfolios. Then in case of healthcare, we are understanding the probability of the patient, whether that patient is going to develop any kind of certain health conditions in future or not, by understanding the medical history of it. Then in marketing, it is really helpful to estimate or to understand the probability of customer purchasing the product next time. When a customer is coming and purchasing the product, we can see how frequently that customer is purchasing the product, right? And based on that, we can recommend, okay, go ahead and purchase this product next time. So we are going to tell, okay, this is our good customer, or just a regular customer or not, right? So those are the different applications or the various areas where we are implementing our quantile regression. Similarly, we can understand now, because we understood all concepts, how it is working. Now we will understand not so famous thing, but we have to come to a real part where we have to understand the mathematical equation on that. I will give you one simple example on this with this mathematical equation which I have shown. So our regular ordinary least square method, how it is coming up, guys. So we have, let me just get the pen. So here what we are seeing, we are observing that we have a target actual value, right? Actual value minus target value, right? So when I'm talking about least square, we are taking each actual predictor with the target value, and we are getting the difference, and after that we are squaring it. Then we are adding it up, like you can see, from 1 to n. So that is our criteria, right? That is our criteria on how we are getting that average regression line on our predictor. Then in case of quantile regression, there is a small change. There is a small change. For what? We are understanding how it is minimizing the weights or the asymmetric weights of the absolute residuals. And here, what is the formula here? It's just we are adding this eta symbol, right? So when we are talking about eta, that is nothing but a quantile loss function, or also called as a check function, right? Quantile loss function is a attribute, or it's a metric which you are adding to the real to the OLS, and it is becoming your quantile regression formula. And these are the conditions on that. So this is your when you're talking a positive residual, it is getting treated with this, and when we are talking about the negative residuals, then we are getting this is getting treated with 1 minus eta. So this is your eta symbol, right? When and that's it. I mean, that is the main condition. Here we are we have to understand how quantile loss function works. This is the main driving factor. And I'll give you an example how we can predict in real scenarios. So suppose we have income and we have years of experience, education. So we usually, what is happening, right? We are understanding that we have a common understanding in our society that the person who have good education, they can earn more, or they can that their income should be good, right? It's a direct proportionate. When we're talking about OLS, we will not go ahead with the average understanding. We will go ahead with the quantiles, right? So at 10th quantile, if we'll observe or if we'll analyze, there are few things which I wanted to highlight. That there is a chance that the education increases income by, or the low income group, by 5,000 per year. There is a chance. That means it's a good number as compared to the low income group. When we're talking about the 90th percentile, we can assume that, okay, the education increase the income by 20,000 per year. That means the education level is same. However, there with 10th percentile, we can see that the range of increasing the salary or the increasing the income per year is 5,000. However, in case of 90th percentile, we can see this with the same education, the amount or the income is getting increased by 20,000. So we understood that assumptions right here. So you can see that it is affecting in different income levels. However, we have a common understanding that no, education good means income should be good, but we don't know the real pattern on how it is working. This solves the problem, quantile regression. And we have different metrics used for quantile regression. Like I have already mentioned, that quantile loss or the pinball loss. So with that, we are going to consider different quantile labels, just the way I have showed 0.1, 0.5 and 0.9. And we will calculate the quantile loss. So this is the formula for quantile loss, right? So this is the loss function, and we are considering actual and predicted. And if we are considering the median regression or the 0.51, then that is going to become a mean absolute error, right? Because we are considering only the absolute values present here, correct? We are not going ahead with the least square. And for the other quantiles, it is going to either it is going to penalize whether under or overestimates happening based on the weights, right? Based on the weights with eta and 1 minus eta, like the way this formula is getting derived. And it helps to understand, or it helps to fit the model based on that nth percentile or the nth quantile. And if you are computing quantile loss across different these quantile value labels, right? That is nothing but a data. It gives you a visual summary. Like you can be able to understand and you can compare between different quantiles how it is performing or how your model is performing. We will see that in a real time example in our next video. Then we have mean absolute error, right? This is again one of the important factors. So overall, if I'll ask you what are the metrics, then you can just go ahead and tell that we have quantile loss, one of the metrics, and we have mean absolute error. So mean absolute error is your median, right? At 0.5, whatever we are getting, we are going to consider that as a median regression or the mean absolute error value. And MAE value and quantile loss will be always identical at 0.5. Just keep that in mind. Okay. Then we have root mean square error. This is just a metric which you are using across all models, because here this is a comparison factor for everything, and I have shown you in our previous videos while working with regression, that how my RMSE is changing the pattern on different models, right? And we have pseudo R squared for quantile regression. So if pseudo R square value is 0, that means model is not better than intercept. Only that value, only the intercept where it is crossing that line, we are going to take that. We are not, like, it is not behaving well. And if it is 1, like pseudo R square is 1, then it is a perfect fit. So that is all, guys. And we have one more thing, which is a coverage probability or calibration. So this is the one where 90% of observed value should be below predicted 90th quantile, and the same thing should be equally calibrated with this one. And these metrics are not so important. These are not so important. Just I have covered it for your reference. However, whenever you are talking about metrics, you should always keep it in mind: quantile loss and your mean absolute error. That is all. And with this, we have covered quantile regression, and we will understand the real-time example here in our next upcoming video. Thank you. That is all for now. We will cover the real-time project part on quantile regression, where we are going to understand on how quantile regression is predicting the correct quantile or the correct predictor variable based on the percentage. So we will see that, and start subscribing if you have not done that. If my content is really helpful for you, please do that. Like, share your comments, share your feedback, and like I have already mentioned, don't forget to hit the bell icon to get all the latest updates. See you till next time. Thank you.